So section 3.2, solving systems of two linear equations by substitution and elimination. So we did by graphing before. This way is just a little bit nicer to use. You don't have to worry about the human error that comes with graphing lines. So first, by substitution. This means we need to get one of the variables by itself and then substitute that into the other equation. So in this case, this x is easy to get by itself. We could subtract the 3y from both sides. And now notice x is by himself. We can now substitute this whole value in for the x in the other equation, because this is equal to our x. So now we would have 2, and instead of x, this whole expression, and then minus y equals negative 10. Notice now we only have one variable in our equation. Our one variable is y, so we can actually solve to get that y by itself. So now notice we have our y value. We can now use this and plug it into our expression here and figure out what our x is. And remember, we found out our y was 4, so we just substitute in 4 for our y. So our answer is negative 3, 4. But what we still need to do is check it to make sure that this is correct. And so to check it, we still need to plug this into both equations and make sure it works. So using our first equation, so it works in the first equation. Trying the second equation, it also works. Since it checks in both, this is our answer. Helpful hint though, if it does not check, if it doesn't work when you check it, this means that you made a mistake somewhere. So if it doesn't check, that means you need to be going back through your work and figuring out where you went wrong. So, same idea, solving by substitution. Notice there isn't an easy variable to get by itself right now, so we can just pick one. I'm going to just go with this equation and get our y by itself. So we'll have 1/2 y equals 1 minus 2/3 x. And now we don't want that half, so we can multiply everything by 2. Now notice we have y by itself, so we can use that and substitute that value into the other expression and for this y here. Make sure when you're doing substitution, since we solved for this equation first, we then substitute it into the other equation. And it might help to change this 2 1/3 into an improper fraction, which would be 7/3 x. And then we can divide by 7/3, which is the same as multiplying by 3/7. Notice our 3's and our 7's will cancel out. So we'll get x equals 3. And then we can substitute that back in to figure out our y. So our answer should be 3 negative 2. But remember, we have to check to make sure. So it works in the first one. Checking in our second equation. Notice a negative times a negative is a positive. 1 plus 3 is 4. So here's our answer. So using substitution, notice this equation's already solved for y, so let's go ahead and substitute that into the second one. Notice we just substituted it in. Distribute. Notice negative 16 is not the same thing as 7. So what this means, since that's false, is there's no solution. Now on this one, we have to get one of our equations by itself. It doesn't matter which one. Let's go ahead and just solve this one for x. So we added over our 3y, and now divide everything by that negative 2. And now let's go ahead and substitute this into our top one for x. So now instead of x, we'll have 3 minus 3 halves y plus 6y equals 12. Notice we get a true statement. So what this means is we have infinitely many answers, or any solutions. But once again, we need to get our generic form so that we'll have x and something over here that only contains x, no y. So what we have to do is we have to get an equation equal to y so that there's only an x in there. So let's come back and let's just look at this one again. So if we solve for y this time, we'll have negative 3y equals 2x minus 6. Divide everything by 3, or by negative 3. So now we can use that expression. And this would give us the pattern for all of our solutions. Now this one, we've got 3 equations, 3 unknowns, using substitution. So let's go ahead and pick one, and I'm going to try to color code these as I go. So this, when I deal with that, I'll try to always use blue. This one I'll try to use green, and this one I'll try to use red. So let's start and get one of these variables by itself. I just picked this one and got y by itself. And then I substituted that one into the blue one. So then I had 2x plus 2, and we're substituting it in for y. So making the substitution, we will still have an x and a z in here, but that's okay. Let's get this simplified as much as we can. Now let's pick another 2 and get it so that we have an x and a z. So let's look at this third one, and once again we're going to substitute this y value in. We'll get negative 2x plus 3z equals 6. Notice now, both here and here we have equations with x and z. So now we can do what we'd been doing earlier this section. We just had 2 equations. Get one of them down to a single variable, substitute it into the other one. So let's go ahead and just solve this first one for z. So we'll have 5z equals 10 plus 4x. Z equals 2 plus 4/5 x. And now let's go ahead and put this one into here for our z. Notice now we only have one variable in our equation, so this means we'll actually be able to solve it. Subtracting our 6 over, we'll get 0, adding like terms. So now we know that x equals 0. Now we can substitute that in over here. And if x is 0, z is going to be 2 plus 4/5 times 0, or z equals 2. And now we can come back up to our y. Up here, and y is negative 3 times x, which was 0, plus our z, which was 2. So our y is 2. And just like before we wrote our answers as an ordered pair, we now write our answers as an ordered triplet, going in alphabetical order. So x is 0, y is 2, z is 2.